Well, obviously it's Friday and I'm not in the classroom. I'll try to be back on Monday, but my apologies. But here we go one more time. This just reminds me how much I disliked teaching during COVID when I was at home and my students were at home and we're doing this over the internet. It's like this is just no fun at all. But we're gonna do the best with what we can. I apologize for not being in the building. I should be well enough by Monday. We want the area of each circle. We want approximate and exact. So let's do the exact first, right? Radius looks like it is just 1, right? Where's my marker? All right. Radius looks like it's 1. So 1 squared times pi is going to be 1 times pi, which is pi. There's my exact value. Approximate value, 3.14, right? Pi is 3.14. There we go. Number 2. Looks like the radius is 3, right? 1, 2, 3. Radius is 3. So 3 squared times pi. Well, 3 times 3 is 9. So the exact area is 9 pi. Now for approximate, I got to go 3.14 times 9. I get 28.26. Number 3, this circle looks like it has a radius of 5, right? For the radius, you gotta go from the center of the circle out to the circle. This looks like a distance of 1, 2, 3, 4, 5. So I gotta do 5 squared times pi, or 25 times pi. That's my exact value. And then for my approximate value, I gotta do 3.14 times 25. This is going to take me a moment. I'm doing this on the fly here. I was not planning on having to do a video of this, but it's quite obvious that I'm not going to make it in. So 78.50 is what this is looking like. And I don't really need the O, right? I can just put 78.5. I don't need zeros behind that last digit there. We're supposed to be here by tomorrow. All right, so let's take a look and determine if the 3 lengths or sides of a right triangle. Right, this should go real quick and easy for us also. Right, this is when I gotta do 6 squared plus 8 squared. Right, I'm going really fast because you should just be checking your answers here. That adds up to 100. 10 squared is 100. So yes, that matches. Number 5. Again, I'm going lightning fast because you should just be checking your answers here, right? That adds up to 34. 7 squared is 49. No, those do not match. That does not make a right triangle. Find the missing side. Again, I'm going to go through this lightning speed. A squared plus b squared equals c squared. So 3 squared plus 4 squared equals c squared. So 9 plus 16 is c squared. 25 is c squared. That seems unusually large. It's because I haven't done the last step yet. I got to take the square root, and we get 5. Square root of 25 is 5. You've probably memorized that triangle by now, 3, 4, 5. Again, I've got to start out with a squared plus b squared equals c squared. Now this one's a little bit different because one of the legs are missing. All right. 15 times 15, a lot of you have memorized this one at that point. 17 times 17 is 289. Now, instead of adding, because I'm trying to find one of the shorter legs and not that hypotenuse, which is the longest side, I'm going to actually subtract. Right? I actually end up subtracting instead of adding. And then, of course, the very last step, I got to take the square root and we get an answer. Okay, learning target. We've talked about the radius of a circle already. We've talked about the diameter of a circle. We have learned how to find the circumference of a circle, both as an exact value and as an approximate value. And we've learned how to find the area of a circle, both as an exact value and as an approximate value. So what we're going to practice with today is like, hey, if I give you one of those four values, you should be able to find the other three. Now remember, when we talk about the radius, it's half of the diameter. If we talk about the diameter, it's 2 times the radius. If I want the circumference, now this is the only one where I got a choice. I can either do pi times the diameter to get the circumference, or I can do 2 times pi times the radius. Right? If I know either the diameter or the radius, I can get the circumference. That's the only one where I really have a choice. Now, for the area, I have to know the radius, right? I need pi times the radius squared. I cannot work with the diameter there. Okay, so let's see what we are doing here. Right? For an exact value, we'll use the pi symbol. For an approximate value, pi is relatively close to 3.14, so we'll just multiply by 3.14. All right, so I got to pause here because you actually need the next worksheet, because these were not examples I was going to try to have you copy down from the PowerPoint. So you got to pause or stop the video here. Make sure everybody has a copy of the second worksheet. And I'm going to work on the first 6 questions with you. All right, so we'll kind of see what kind of twist is coming up. Okay, so hopefully if it's still running here, you've got your... Okay, let's work through some questions together here. Question number 1, the radius is 5. Well, I know radius is half the diameter, so diameter is twice the radius. So 5 times 2 is 10. Right? 5 times 2 makes 10. Circumference, it's pi times the diameter. Notice we put the number 10 before the pi symbol. Right, it's kind of goofy because the equation that we use, C equals pi times the diameter. When I do pi times 10, I actually write the 10 first. Now for area, it's pi r squared. Well, I know 5 squared is 25. I've just got pi times 25. But again, mathematicians have agreed that we'd put the 25 first and call it 25 pi. All right, the reason why the pi is coming first with the equation is that the r is a variable, right? Or over here, that d is a variable. And so they're going to put the number pi before they put a variable. But then when we're looking at answers, right, now we have a number of 25. We don't have a variable anymore. And so that's why we put the digits of the whole number first before we put the pi symbol, which is the irrational number. Right? Mathematicians just sometimes have to come up with agreement on how to do things. Number 2, let's see, if the diameter is 6, what's the radius? Well, you know, the radius is half of the diameter. Half of 6 is 3. For the circumference, you just take the diameter and multiply by pi. There it is as an exact value, 6 times pi. For the area, well, I need pi times the radius squared. Again, I got to do a little bit of math here. I got to figure out 3 squared. It's 9. So 9 pi. Right? Notice finding the area of a circle can actually be much quicker than like finding the area of a triangle or a rectangle. The multiplication is much simpler, right? Because you just put the pi symbol there when you're multiplying by pi. Number 3, oh my goodness, I don't know the radius, I don't know the diameter, but I'm given the circumference. How do we work backward? Well, I know the circumference is pi times the diameter, right? Circumference is pi times the diameter. So if I know the circumference, and I know it's pi times the diameter, well, I see the pi symbol, that means that 8 has to be the diameter, right? That 8 is the diameter. Of course, half of 8 is 4. Our radius is 4. For the area, I got to quickly figure out 4 squared is 16. Oh, well, the area then will be 16 times pi, right? Because if I want the area, I square the radius, and then I multiply by the number pi. But if I want an exact value, I can just leave it at 16 times pi. Now, trickiest of the bunch might be when we start out with the area, right? I got to work backward, knowing that the area is 36. And with the area, well, how do I work backward? Well, we can get the radius from the area, right? Hey, I know it's pi times the radius squared. Well, I know that the radius squared has to be 36. So what's the radius? Well, thank goodness we've been practicing this for quite some time, right? Like, why have we been practicing square roots? Well, first of all, we need to know how to work with square roots. But second of all, the curriculum for this unit has us working with the circles. And if I want to go backward from the area, I got to be able to take a square root. Right? So the square root of 36 is just plain old 6. There's my cursor. Double that, you get the diameter of 12. Circumference, take the diameter, multiply by pi, and there we go. If you want to challenge yourselves and try to do number 5 ahead of me, you might want to just pause the video for a moment, try to get the answers for number 5, and then resume the video. Okay, I'm guessing you're back here. If we start with the circumference, that tells me the diameter had to be 14, right? 14 times pi is the diameter. I'm sorry, it's the circumference, right? 14 times pi is the circumference. And of course, that is just the diameter times pi. So if I've got the circumference and I see that pi symbol, I know that other number is the diameter. So I know that 14 is my diameter. Half of 14 is 7, so I know my radius is 7. For the area, again, I got to square the radius, right? I got to figure out 7 squared. Well, 7 times 7 is 49. Area is 49 pi. If you want to try to challenge yourself and do number 6 before I put any answers up there, why don't you pause the video, see if you can get answers for number 6, and then you can resume the video when you want to check. Okay, let's assume that you're ready to check or follow along if you didn't quite get through that. Say, hey, again, if I know the area, I know that 64 is radius squared, right? And so I know the radius is going to be the square root of 64. So the radius is going to be 8. Right? 8 times 8 makes 64. If I double that, I'll get the diameter. So 8 times 2 is 16. And then for circumference, I just take the diameter times pi, so 16 times pi. And there is the answer written as an exact value. So time for some independent practice. Notice that you can work on some more of these questions where we're going between the radius, diameter, circumference, and area. And then when you get done with those questions, we've got some extra practice from earlier in the unit.